so questions on the review from 5.1 or 5.2. Again, the solutions were on the extra, or the general information module, but they're here. All right, so again, on the chapter 5 module, at the end, right where it says chapter review, there's a thing that says chapter 5 extra practice. So I built this page that goes by the sections. If you're good with 5.1 and classifying triangles, obviously you don't have to worry about that stuff. But if you want some extra proof practice, there's a video and then there's 2 PDFs, okay, that can help you with some extra proof practice there. If you need the extra practice on the CPCTC, there's an extra practice. It got cut off on this picture, but there's an extra practice proofs involving CPCT there. So you just need to figure out, you need to be really self-aware where it is that you're struggling and then what you need the extra practice with, and there's some extra opportunities there. How about 5.3, 5.4? 14? Okay, so in 5.4, this was isosceles and equilateral triangles. The diagram that's given to you there has 3 triangles if you count the big one. But the 2 smaller, this triangle on the right has all 3 angles marked, right? So if the 3 angles are congruent, what's true about their sides? They're also congruent. So when I find one side, if I find this side, it's the same as this side, which is the same as this side. Those 3 would be congruent. If you look at the first one, the other triangle, this one, it gives you the 2 angles are congruent. So what kind of triangle is this? Isosceles. If those angles are congruent, then the sides opposite them are also congruent. So the 26 that's on the left would go here to the right, and then 5y plus 1 would equal 26. 5y would equal 25, and y would equal 5.
Because 5y plus 1 is all.
These 2 are the same because these 2 are the same, right? And then what's true about an equiangular's angle? 60. This is 60. This is 60. This is 60. The angle here, 8x and 60, are a linear pair. So 8x plus 60 have to add up to 180. 8x would be 120. Divide by 8. 115. Did it ask for just x and y? Yeah, x and y. Yeah.
How do we find out that the second pair of congruent angles are 60 again?
Because on the gray triangle, which is equiangular, they'd all have to be the same. And if they're 180, that makes them all 60. Yeah, that was one of the corollaries too from that section. So are they? Because these 2 angles here form a linear pair. So the 8x from the one triangle from the green triangle and the 60 from the gray triangle are a linear pair, which means they form 180 degrees. Any other questions from 5.3 or 5.4?
Oh.
All right, 5.5, 5.6. So side, 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 angle, side, angle, and angle, angle, side. Jonathan. 15. Okay, so it said to decide whether enough information is given to prove that they're congruent using the side, side, side theorem. If so, write the proof. If not, explain why. So what you have so far is the one pair, right, marked as congruent. And then what do you have that's not already marked? The reflexive side. So I have 2 of the 3 sides, not all 3. And that's why it's not enough.
I don't know if this is also for lines, but the third angle strip.
No, it doesn't work.
It's only for angles.
Only for angles. Yep. So this is not enough. Not enough. You need all 3 pairs of sides.
I'm so good at this. This is why I'm really good at this.
I hope you're right.
This is why I hope I get it.
Anything else from 5.5? Because 5.6 is actually on the other side. Okay. 16 says to decide whether enough information is given to prove the triangles are congruent using hypotenuse leg. So for hypotenuse leg, you have to have the right angle, which you have. You have to have a pair of legs, which you have. And you have to have the hypotenuse. It's not currently marked, but can you prove that that's congruent?
Yeah.
And why? Reflexive. So you could have made this into a proof. It could have been 1, the given, wx equals zy, and angle w equals 90 degrees, and angle y equals 90 degrees. Or that they were perpendicular. That could have all been your given. Step 2 would be that zx equals zx, and that would be reflexive. Step 3 would be that the triangles are congruent.
Would you ever have to state that they're right angles or right triangles?
No, one way or the other, that it's given as 90 degrees or that they're perpendicular. If it was perpendicular, then I would say that it has to be 90 degrees. You'd have to say, or a right angle. Yeah. Let's say it then asks for you to actually go a step further and prove that WZ equals XY. Could you do that?
Yeah, that is CPT.
Good.
If I
C.
spell it wrong on the test,
I mean, if you can get pretty close, maybe, but if you start making up a whole CPCTC, congruent parts of congruent triangles are congruent.
I thought there was corresponding.
Corresponding parts of congruent triangles are congruent. It's not congruent 3 times, yeah. 5-6 and 5-7.
Wait, well, why did you skip 16?
All right, so 22 says write a plan to prove that 1 is equal to 2. So this is like a really informal because it's a plan, but we can actually turn it into a 2-column proof. So what would be given to you, right, is all the stuff that's marked. SV equals VT, QS equals QT. So then how am I going to get from these smaller triangles to those outside angles? What's the link there?
I can do one.
Yeah.
Can I do?
We're going to do this to make life easier. I'm going to make them 3 and 4. But let's just say it didn't say that. You would use the 3 letters.
3 equals 1,
Okay, and how do you know that?
and 1 and 4 equals 2 because of vertical angles.
Good. Vertical angles theorem. So definition doesn't say they're congruent. Theorem says they're congruent. Okay, so I know I can get from 3 and 4 being congruent to 1 and 2 being congruent, but how do I prove 3 and 4 are congruent? Before you do that, what do you got to do?
Prove that the triangles are congruent.
And so to do that, I need the reflexive side. The reflexive side is here. Interesting. That's reflexive. So now I would prove the triangles are congruent. QSV, QTV, and it's side, side, side. And then I can say angle 3 equals angle 4. CPCTC.
Because of the corresponding parts of congruent triangles are congruent.
Good. And then angle 1 equals angle 2. And that's substitution because it was 2 transitive statements, basically. If you went just one at a time, then you can use transitive. But we substituted both. We substituted 3 with 1, which is what it equals, and we substituted 4 with 2 for what it equals.
All right, now I got it. Now
I think that's harder than what you'll see tomorrow, but if you can do that, you should be okay.
that's hard.
What'd you do? You did the reflexive side, yes?
I did that. Okay, I did that. CW is parallel to XY as the given,
Yeah.
and then I put that the angle of WZX is equal to YXZ because it's alternate interior,
Yep.
and then I did WXZ.
Yeah, so you can't do those. That's why. If you have these two as parallel lines, right? And this is your transversal. These two definitely work because they're alternate interior. But the whole angle out here equals the whole angle out there, not just a little part.
Wait, so YZX is
No. Both pairs would have to be parallel for you to do that. Because it has to go all the way to the transversal. I mean, it has to go all the way to the parallel line, so it'd have to go outside your box.
Oh, so now I got this wrong.
All right, so you see these are my parallel lines, right? And this is my transversal. Alternate interior here and here work because it goes from the transversal to the angle, but the other one from the transversal to the angle is that whole angle. From the transversal to the angle is that whole angle.
So it doesn't work.
Because you have the stuff outside the box, you can't say that that's the same.
So
Yeah.
they're not congruent.
Correct. If it gave you both pairs of parallel signs, now you've got it.
Wait, so the angles that are congruent are the angles that are enclosed by the transversal?
And the parallel, exactly. Yep.